Very good morning to all the participants to this special day of splendor. I hope you're all staying safe, sheltered in place, and healthy during these absolutely unprecedented times. Once again, thank you so much for joining and participating in webinar organized by Indian Concrete Institute, Pune and Ghaziabad Center. I'd also like to extend my warm greetings to the distinguished dignitaries present with us today. The session is on a very pivotal and intriguing topic, that is construction saga of Bahai House of Worship, Lotus Temple, which is a landmark monument of India. The webinar will enlighten on points like uniqueness of structure, challenges faced, and solutions delivered by experts who have witnessed and have been part of construction of this iconic structure. Moving on, I feel glad to welcome Engineer G.K. Sahu, Senior Scientist at CSIR CRRI and Chairman of ICI Western UP Center Ghaziabad, for a brief introduction of Indian Concrete Institute. Over to you, sir.
Thank you, Divyanshi. Let me allow to share my screen, please. Are you able to see my screen?
Not yet.
Not yet, sir.
Happen just 1 minute. Sometimes it takes slightly. Are you able to
Here
see?
now. Yeah,
Yeah,
make it in a presentation mode.
Yeah. Just I am checking whether it is changing or not. Sometimes it creates problem. Let us see. Changing?
Yes.
Yeah. Now we can. Yeah.
That's right. Perfect.
Yeah. Good morning, everyone. I welcome all our participants. There may be more than 4,500 participants in line. I just welcome all my seniors from all departments, that is from our own colleagues, ICI, other department technocrats, bureaucrats, and even our foreign delegates. I welcome all my speaker, moderator, our vice chairman Rahul Goyalji, and organizing authority from Ultratech, both the team from Pune and from Delhi, and chairman ICI Pune. I welcome all of you, sir. And you see the brief objective I will just show you from ICI. And today our topic is actually, you see, construction of Bahai House of Worship, that Lotus Temple at New Delhi actually, and you will enjoy definitely this topic. What happened that all the photographs, if that we can eliminate from the slides, please. That is, if you can eliminate, so that you can see whole slide or something. Yeah. So ICI journey started in 1982. At that time only we were having 500 members. Then at present you will find 45 regional centers throughout the India, and you will find more than 30,000 members, 300 more than 350 organizational members, more than 250 student chapters. You can see anybody can become member of ICI. That you can see the combination: practicing engineers, consultant, manufacturer, research scholar, academician, student, anybody who is interested in concrete, they can become. This is our governing council. Similar, we are having our individual centers governing council, that is chairman, vice chairman, secretary, treasurer, and executive committee members. Around 10 people will be there. And you can see the objective of ICI. Basic objective is to fill the gap between the R&D activities and the site. That is the basic objective actually. And for that, we have to do several things that you will see in my slides. You can see we have to organize seminar, webinars. We have to identify R&D problems. We have to collaborate with national and international agencies, and many things we have to do. And in that, to get that aim, we are organizing webinar. So from last May, that 29th May was the first webinar. That is the international webinar for 3 days, and we covered 18 lectures there actually. So that is our starting point, and from that onwards, we are trying to come every week. And today in that series, we are in the 36th webinar, and this is 65th technical lecture. So you can see some of the pictures of our activities that we are doing. This is the our concrete day function last year. Yeah, before that you can see in 2019, and there we enjoyed the presentation, the Statue of Unity, that we enjoyed. You can see several award functions, ICI of all the centers. You can get some function every year. Yeah, you can see uh, many cultural programs also, and many demonstration work. And these are the actually awards which our headquarters is every year giving to promote whoever the contributing concrete technology. These are the journals we are producing, and you can see, you can just go in ICI website and you can access everyone. We are having many manuals, very useful manuals. You should refer these, and we are having our student chapters in several colleges, and they are also doing very well. They are organizing workshops and that field visits, these type of activities. So I request all of you to just go through the Indian Concrete Institute website, and whosoever is not member so far, he should become the member of ICI. We are committed to promote concrete. Last in webinar, we have enjoyed in the building field. Now we are in the field of construction of Bahai Temple, and really, I think you will definitely enjoy this session. Thank you, everyone. Now I welcome all dignitaries once again. Thank you, Divyanshi.
Thank you so much, sir, for giving the brief. There's an announcement for all the participants. I'd request you all to please post your questions in pertinent to the topic in the chat box, and we'll pick up those questions at the end. Now, I feel honored to introduce Mr. V B Gadgil, who is Director at CQRA Private Limited. He has an extensive experience of 44 years in construction industry. He has shrewd business acumen, quintessential leader, and an eloquent extempore orator. Mr. Vivek speaks on various topics at leading educational institutes, business school, and manifold professional forums. In addition to this, he was former Chief Executive and Managing Director for L&T Metro Rail Limited, based at Hyderabad, and has also worked as Senior Vice President of L&T Construction. It is because of his unceasing maneuvers that he has been awarded the Lifetime Achievement Award 2015 by American Concrete Institute, Infrastructure Person of the Year 2015 by Construction Week magazine, and Udyog Ratna Award by the Institute of Economic Studies of India. With a propensity for hard work, indeed, Mr. Vivek Gadgil has set a significant milestone. So with this brief introduction, I request sir to please take the time over from me and enlighten the participants with his golden words. Over to you, sir.
Very good morning to all who are witnessing this excellent webinar, I would say. And I would like to say something about the topic itself first. We are going to deal with really a construction saga of a monumental structure, probably of the world. It is not only the monumental structure in India, and it is rightly said so that it is a construction saga, popularly known as Bahai House of Worship or Bahai Temple, situated in Delhi. It's really a marvel of engineering on all respects, right from starting from the analytical geometry to the execution. The whole topic is so intriguing and interesting, and not only from the engineering perspective, but it also showcases the human spirit of innovation and perseverance. The particular topic on which we are going to deal here for almost 2.5 hours is really to the heart of some of the people present here, and they are so passionate about particular project. Here I would like to tell something about this, that this particular project always reminds me of third law of Newton, and I'll be definitely sure that everybody must be surprising. How can I connect third law of Newton to this particular project? Because here it is that when the action is strong, action is demanding, there is an equal and opposite reaction from the other end. Here the action was given by the architect Sabha of requiring excellence. To be excellent in all aspects and also demanding a very, very meticulous and ultimate requirement in every aspect of quality. And it was because of his action, there was an equal reaction by, I would say, the people who were involved right from the engineering side to the construction. And that is why it always reminds me that Newton has very rightly said there has to be a good action and there will be 100% reaction, equal and opposite 100% reaction to that. Now, having said about this particular project, I would like to tell you that structurally also this is very, very intriguing. And we used to very proudly say that the shell thickness of this particular monumental structure is almost equivalent to a thickness of an eggshell. If you really either minimize this structure to the egg size, what thickness of the shell you will get will be the shell thickness of the egg. And that is the indigeneity of the structural design. So having said that, we are going to have very, very elaborate discussion on these things. And I would like to tell that both the speakers, the presentation will be made by Mr. Shyam and finally concluded by some discussion between myself and Mr. Ganguly. Mr. Seth and Ganguly were directly involved during the construction of this project at site. And here I would like to first go ahead. I had mentioned about the architect, Mr. Februz Sabah, and what was his actually dream. His dream was to design a temple which has cultural roots in the rich heritage of India and at the same time is compatible with the cardinal principles of Baha'i faith, that is the unity of religions. This provided a most unusual and remarkable chance for witnessing the power of Baha'u'llah's revolution. He was looking for a concept that would be acceptable to the people of different religions, that would abound with such a rich diversity in India. He wanted to design something new and unique, at the same time not foreign but familiar in a way. So this was his dream. Of course, Mr. Ganguly will tell a lot of things about him because he had a lot of interaction with Mr. Sabah during and afterwards. So having said that, now I will try to introduce both the speakers first. So Mr. Ganguly, a stalwart in Indian construction of having more than 40 or 42 years or 44 years of experience in different aspects of the construction. But one thing I'll tell you before I read out whatever is written about this, that he is a driver of quality and excellence. Wherever he goes, he is extremely, I would say, demanding in quality. He is a civil engineer graduate from IIT Kharagpur. He worked with MES for a short time in factory and residential institutional building for ordnance factories and the defense forces, but I am sure he was uncomfortable there. Then he moved to L&T Construction at that time, that is Engineering Construction Corporation, wholly owned subsidiary of L&T, and worked on various industrial and commercial projects and monumental projects. As we rightly say that he is a man of bridges, and he has done some really monumental works in India and of course abroad. He has also worked in Indian and Iron Steel Company for some time. But like I told you that Mr. Ganguly is known for his demand of quality in all way of his life. And we always looked at him as man of excellence, demanding high excellence. He is going to deliberate on the subject. He is very passionate about the construction, the quality, and especially this particular project, that is Bahai Temple. That is Mr. Ganguly. We'll hear more from him. The presentation is being made by Mr. S.N. Seth. S.N. Seth is an eminent speaker. He is chairman of Premises Advisory Committee of National Stock Exchange. He also has got 4 decades of experience in providing business, strategic and operation leadership, wide experience in industrial, petrochemical, residential, commercial buildings at various capacities and positions in L&T. He was also former head of Elite Housing Business Unit in L&T Construction, and he also propagated use of aluminum formwork and precast concrete construction in residential buildings while he was as a COO of L&T Realty. He is civil engineering graduate from another prestigious institute like IIT Roorkee, and he was there almost throughout the project construction, starting from the planning stage to actual execution. And he will take us through the integrity of the structure, the general planning of the structure, and the challenges different times we met. I would like to just brief upon certain things that this is highly intriguing but interesting subject. 2 hours and 2.5 hours are not sufficient to really get to the thread and the bottom of the heart of complexity of this project. So I would like everyone to be focused on today's topic of construction saga related to the construction. Of course, all related questions are welcome, but given the time constraint, we would be brief in all the deliberations, basically to make you people aware of what was then done when the most of the technologies, modern equipment, modern tools were not available. And that is why I always say it is a good example of human spirit of innovation and perseverance. So if anybody wants to get into the technical details, understanding the various design details and all these things, I think this will not be, or this may not be a right forum. But we would love, and actually I had been requesting, I was telling somebody, it may be an exaggeration, this particular topic can be a research project for many of the research scholars for almost 2.5 years of work. So you can understand that we are going to compress that kind of complex project in 2 hours. So I will now hand over the presentation and welcome Mr. S.N. Seth to start its deliberations. Thank you.
Thank you, Mr. Gadgil and other eminent member on the panel. Welcome all the participants across India and abroad. As all of us know that now Lotus not only represent Delhi but India whenever we talk about them in media. The Lotus was designed by Mr. Saba, explained by Mr. Gadgil just now. He was a Canadian citizen of Iran origin. The structure design of the Lotus was done by Fried and Neil Partnership of UK. Currently, I feel it has been taken over by COVI. And we were there from L&T-ECC, now known as the L&T Construction Division. Lotus itself was 34-meter height and 70-meter in diameter, and cell was self-supporting RCC shell structure. Groundbreaking was done in 1978, and full project with all the marble and finishing was completed in 1986. Next slide. Next slide, please. As explained with the passion, Sabha traveled across length and width of India and picked up the half-bed, half-open lotus to symbolize his structure. The repetition of 9 for each element was picked up by him from the 9 religious prophecy of Baha'u'llah. The budget was $10 million at that time. Can we go to next slide, please? Can we go to next slide, please? Situated in Bahapur, Delhi, it is on 24-acre plot around 1,05,000 square meter area. The main lotus covers the main assembly hall where 2,500 fellow can assemble and 1,300 fellow can sit. MEP is in the basement of the building. The ancillary building covers the reception, administration, and library. There's a space for car parking and main gate. Can we go to the next slide, please? Seeing from outside, we see the 3 main leaves. Lotus looks made out of 3 type of leaf. The entrance leaf, which provides the entry to assembly hall from all 9 directions. The outer leaf, which projected inward, and the tallest leaf, inner leaves. Main assembly is at the podium, and there are 9 pools around the lotus, giving a floating petal look. Can we go to next slide? There's a cross section across the full building to give you the detail of each and every element which I will be covering. My main learning came and my main familiarity with the complicated curves and of the project of the lotus came from making of this working model, for which I was associated, and I have to redo almost all the calculation in a lower scale to make this working model, which I will be covering before taking up the construction part of the project. Can we go to next slide? To recap, there are 9 plus 9 plus 9 leaves, entrance leaf as an entry point, outer leaf to cover the annual space around the main assembly, inner leaves cover the assembly. On the top, these leaves get separated and joined by the radial beams toward the center hub, which houses the fan room. Can we go next slide? When you go inside the building, you see the beautiful butt look, which is made out of rib beams and the shells, which disappear at the center hub. There's a skylight coming from the top. Almost all 27 leaves are supported on the arches and the M column in the podium, which takes all the load of the superstructure to provide for movement, thermal movement, and wind movements, temperature movements. The lupin pads are provided below the arches and the M block column, and also between the hub and the radial beam center hub. The water inside the pool cool the assembly hall during the hot weather of Delhi. We can go to the next slide. To comprehend the geometry, we have to understand that how the sphere, cylinder, toroid, and cones can give the different sides of these leaves. Those geometrical curves were converted into the equations which were used for structure analysis and making of engineering drawing. The geometry was so complex that detailed drawings would have taken more than 2.5 years before the actual work started. Those geometrical equations were to be integrated to get even the small sizes of the formwork, reinforcement rod, staging material, calculating the quantity of the part of the structure wherever the material to be ordered or the work to be executed. The complex geometry was also converted into the, at every stage of the construction, has to be converted into the model, mock-ups, full scale representation with the help of stagings and other topolines, etc. So the workers are able to comprehend it. We are talking about the last century, 1970, when AutoCAD and PC were not heard of. We can go to the next slide. Correlating the various leaves to their geometry, the external entrance leaf and outer leaves were made out of the spheroid, while the entrance leaf was made out of inner surface and outer surface were on two spheres which didn't have the common center, giving the varying thickness from valley, the lower places 150 mm to the 300 mm at the edge. Outer leaves were the spheres of the same center. The thickness below the glazing, which was covering the annual space, was 133 mm and 255 mm above the glazing line. This 133 mm along with 60 mm of the dome was the real challenge, which I will be covering in coming slides. The inner leaf was a peculiar shape. It is taken out of the toroid surface. This torus is nothing but a small circle rotated around a single line, which is outside the circumference of the circle. Yeah, it's where analogy can be the cycle tube or the card tube. Inner leaf was uniform thickness of 200 mm. These leaves were 34.3 meter for inner leaf, 22.5 for outer leaf, and 7.8 meter for entrance leaf height from the podium. Can we go to the next slide? Before we go to the next slide, I also want to share one very important component. The full geometry was designed in a radial symmetry of 40 degree. Each element was repeated in 40 degree segment, which mirror itself in every 20 degree. Coming further elements like arches. Arches were again the further complicated geometry. The soffit of arch was parabolic conical surface. Other sides were inclined planes and cylinders. Arches were, as already explained, were the very important structure which was taking the load of almost full interior dome and full leaf and sharing the main load of the outer and entrance leaf. The interior dome itself is a complicated geometry. We understand, or you will surprised to know, it is the 9 spheres intersecting each other in crisscross way. There's 3 radial ribs beam will start from the top of the arch, center being directly supporting the center hub below the radial beams. The other 2 leaves go and meet with the other rib beams of the other arch, and another intersection. On the intersection, another 1 more rib will start to support the hub. This was repeated to have the vertical ribs which were joined together with 60 mm shell thickness of concrete, white concrete. Can we go to the next slide? You see the parabolic conical surface, how the arches gives a wonderful look, and the inclined planes and the cylindrical surface defining the different part of the arches. This is the outer leaf. You see the beautiful that form finish, the bush hammered concrete, white concrete surface, maintaining the line, radial lines, and the latitude and longitudinal lines of the formwork, which were used for doing it. Can we go to next slide? Now, all this complex that geometry and which is mentioned in the drawing with the levels, equations, others, has to be converted into actual coordinates, distances, and the levels to transfer it to the actual work. We had the coordinate calculated along the main lines, like the cusp line where the two part of the outer leaf meet or inner leaf meet or entrance leaf meet, and the valleys and the edges. But these coordinates in turn has to be transferred to the actual work, which was done with the help of real breakthrough tool, a hand tool. At that environment, when we didn't have that real very great survey equipments, that was a step template, can be used by the carpenter, and the curve template. The step templates were aligned from one coordinate and it will move to the other coordinate with a simple carpentry tool, plumb bob, and the split level. So if you have to do any curve alignment, or you have to stabilize any curve line on any structure part for any activity, you have the starting point and keep on moving to the next coordinate. Use the curve template to align and destabilize the full curve line of a specific leaf, corner, cusp, valley, re-entrance. Can we go to the next slide? Having those distances and level from the coordinates which came out of the equation, this has to be transferred accurately on the structure before the final finished formwork, etc., can be erected. There were 18 reference stations which were stabilized around the building at every 20 degrees. These reference points were preserved right up to the completion of the marble. It's well preserved, and we engineers were they are responsible to provide this transferring these lines to on the structure. Can we go to the next slide? Can we go to the next slide? So suppose a structure is there and work has to start. We will have the cusp line mark on the structure or that layer of the execution with the keeping the 1 second thermolite on the reference station, transfer the pine, stabilize the bottommost level, use the step template, crossing the step template again with the 1 second thermolite, so it is proper vertical in one plane, the other plane with the plumb bob, recheck third plane with the split level, and accurately stabilize the next point. That way we keep on moving. Reaching on the top, again we will hang the tapes and use the level instrument, cross check with the 1 second thermolite to ensure that the main controlling lines are properly stabilized in required shape and dimensions. The things were repeated for the edge line, re-entrant. Curve templates were used to align the cross surface of the structure, whether it is a formwork or it is an internal formwork, whether it is an external formwork, or it is even the marble. Can we go to the next slide? Now, phasing sequence of the construction, specifically in view of the top structure, it was kept in mind that any part of the structure, when concreted and de-shuttered, will be able to stand alone. Inner leaves and the interior domes were done in 120 segment to have a uniform loading on the central structure to avoid the heavy lateral loads. Can we go to the next slide? Next slide, please. So if we see the sequence, after completing the foundation, basement, and inner podium, 9 arches were completed. Central staging was erected. Then inner leaves are cast in 3 steps. First 2 steps up to the radial line bottom. From the arch top, there are 2 parts. Just behind the first cut so that it is not visible. From inside, podium assembly hall, this construction joint is not visible. After completing all the leaves radially at every 120 degree, phase 1, phase 2, in all 3 steps, then radial beams were taken up and center hub was cast, and then the last lift of the inner leaf was completed. The similar analogy was used while doing the interior dome with 123 beam, 3 shells at 120 apart, then again adjacent, then again adjacent. For doing the outer and entrance leaf, it was ensured that first 2 entrance leaf has to be done, which became the base of the starting of the outer leaves. There was a crane put in circular rails which were holding the construction of the bridges and the part of the pool, which were completed after even completion of marble was done and top staging provided from marble is removed. Can we go to the next slide? Now, the staging and formwork. We engineer used to call it a concrete jungle. Maybe the structure still used for the enabling work was more than the main reinforcement still would have gone inside the structure. All these leaves has to be very properly finished, have to be form finished, has to be bush hammered, and the longitude and latitude line has to be left when the work is completed. Deflection, as per the book and as per the codal, might have been permitted 3 mm for 1 meter, but actually every part of the extrusion was done with 0 mm acceptance. Whether it is a curved template or on the top of the formwork, internal or external, or the top of the plywood, even a light passage shall get rejected. So you can say that everything has to be so accurately done, as already explained by Mr. Gadgil earlier in the discussion. The demand was tremendous. It's a 0 error. We used to say that if we can build this and complete this temple, we can surely send our rocket on moons. That also may not require that kind of quality checks. So already explained that construction joint was kept in such a way in inner leaf so that it is not visible on the podium. Staging of the inner leaf was so designed that same with a slight modification can be used for the interior dome just after the completion of the inner leaf. It is a very important design parameter which was taken with all those heavy loads which were considered for the projects. Accordingly, the 9 space frames were erected below the cusp line and the reentrant line of the inner leaf, which were cross joined by the rafter, purlins, and timber decking. There was a smooth transition from the straight line of steel structure to the doubly curved plywood curved surface, which has to be put before the concreting is started. Can we go to the next slide? The design itself for the structure of formwork was done taking the dead load of 750 Newton per meter square, self weight of the steel and timber, live load of 2000 Newton meter square, and wind load of 1000 meter square. The concrete load was considered the higher of dead load of the concrete or the pressure created by the rate of pour of 0.45 meter per hour for the temperature of 10 degrees centigrade a pressure formula was used to calculate the pressure of concrete. The inner leaf structure, complete structure was checked for the very complex and all the stages of the construction. Like if in stage first it is the half done, the first stage of the concreting is done, second stage of the concreting is done, means you have to have the different symmetrical and unsymmetrical loading on the central structures, and the full structure was also cross-checked for the unsymmetrical wind load. Similarly, the outer leaf and steel structure for the entrance leaf was also designed. Can we go to the next slide? As explained that structure steel members were so designed so that formwork can be stable on longitude and latitude lines of the leaf. So for the top member or even some of the members of the steel members were to be bent on both the direction with the heavy jacks to have both two directional bending, that is web bending and the flange side bending. A full scale mockup was created. We understand we used to call it the mockup site, and sometimes we used to wonder when we will do the structure, main structure, actual main structure. For every element before any work is done, we have to do the mockup, understand the geometry, understand the step, prepare the timeline, and execute the job in a given time. So there was a full scale mockup was prepared for almost all the element of the structure. The formwork joint of the leaves were sealed with the POP and the epoxy resin, and in the interior dome case we use the plastic sheet and the epoxy resins. For doing the supporting the outside grillage, we use the pipe support crossing the leaf which were put in the sleeve, and there were the outside grillage supports the main runners and the working platform also. There were shaped timber which were fixed on these vertical runners outside to facilitate the climbing shutter to be fixed while doing the parallel to doing the concreting. This was prepared in a military-like manner, that there were always a mock concreting is done, and top shutters are trial fixed for the portion of leaf up to which the concreting to be done, and then the actual work is started. We can of course come to the when we see a cross section of a typical cross section, we see that what I explained, there's a straight steel member, there's a rafter, steel rafter structure, steel rafter, then our normal this purlin type of purlins what we have from rafter to rafter. We have timber runner, timber decking, we have the timber formwork, and in between the wedges to give the fine alignment, that to remove that light coming in the while checking in the curve template. The same way you see the top shutter which supports the outside formwork. Can we go to the next slide? See, it's a typical cross section of the inner leaf. What explained earlier, that we have got the inside space frame, we have got the visible rafters, we have got the purlins below and the timber decking, and there are the pipe sleeves to support the similar space frame outside at the cusp and the re-entrant line or the edge line through the re-entrant and the edge line, since there's no edge corner in the inner leaf, and it was crossed through the pipe sleeve and the pipe. You will find here this sleeve which is provided were not only used for the concreting time, but the same sleeve were utilized while refixing the space frame for doing the marble cladding. Full grillage outside we are having the working platform. If we see the concrete pressure, it will be like cusp to reintegrate the horizontal lateral member, which is doubly bent, will have a concrete pressure like a triangle like this. Can we go to the next slide? Yeah. Now coming back to the reinforcement. Yeah, reinforcement was a really very tricky for that. Considering the durability of the project, the all reinforcement provided in white concrete portion were galvanized, hot dipped galvanized. Step used to be that cut and bend, spec for the bending crack, trial fix, sand blast, recheck the bending crack, send for hot dip galvanization, and use the galvanized bending wire to fix the reinforcement bar. Here again, the tolerance of fixing was really very, very strict. Considering the durability, there was no tolerance allowed for the cover in the negative direction. Positive, you can have 3 mm more. We used to have the fishing block of 34 mm. We should not go anywhere, and 30 mm we should go everywhere to cross check the cover, to finally align the reinforcement, and the inner surface, which was to be bush hammer, should not have any cover block. There was a hanging screw system was made. From the top village, this hanging screw will go and support the full reinforcement mesh, and the screw will be tightened in half thread, 1.5 thread, to give the precise cover on inner face. Can we go to the next slide? Coming to the concreting, of course, for the reinforcement concreting, I can talk a lot. I have touched up the salient features so that give you the full insight. The concreting was a white concrete. It was to be bush hammered. After the concreting has been done, all pattern lines should be visible. It should look beautiful. The mix has to be designed so that bush hammered surface should have uniform grading, dolomite and that sand. You will see that you will surprised to know more than 40-50 trials were done for the white concrete, and small mockups are prepared. Out of them are bush hammered to see the grading and the retrial. It became really a great art, which I always remember Mr. Ganguly standing, our construction manager standing with our concrete lab in charge and discussing and trying to evolve the final mix which to be used for the concreting. The white cement was not available in India, which was structure grade, so it was imported from Korea. Dolomite were sourced from the Alwar, Rajasthan, and white silica from Jaipur, Rajasthan. The cement consumption of this M30 mix was 380 to 400 kg per meter cube, and to maintain the 100 to 120 mm slump for giving a very smooth concreting and proper setting out time, final setting, initial setting time, a super plasticizer was used as an admixture to the white cement. Temperature was maintained less than 30 degrees, and in Delhi this hot summer temperature, which is more than 40, it is not only ice were mixed in the concreting, but even the air cooler were used for aggregate and the sand, which were covered with the tarpaulins, and sheds were prepared for that. They were staying in a better space than we engineers and foremen and the carpenters at the site. There was a rain protection so that the work continues even during the rain. Concreting was manual placed to give the time for fixing the top shutter and to avoid the cold joints. Can we go to the next slide? Yeah. Now, almost all the shells outside were dry cladded white marbles. They were fixed in again the longitude and latitudes which are visible outside. The marble were sourced from Penticton grease and were cut and polished up to within tolerance of plus minus 1.5 mm in Italy. In the site, we have to cut the corner pieces for the cusp and the edge. The cusp of every leaf will have the inclination for which we made the arrangement for the tool with the steel and with the jacks to give a proper straight lines, and the curve line come out of it to define the curve correctly. Stainless steel clamps were used to fix this, and the stainless steel clamp was having the 10 components, so that it can be aligned in any direction, all three directions, whether you have to provide a bit more gap because of the outside concreting not done with the climbing formwork, or you have to provide the alignment of the marble, which is standalone fix, not transferring any load to the other marble because of the cover meter has shown the steel lot inside, and you have to change the location of the drill required to be made for fixing the clamp of the marble. Marble holes were sealed with silicon sealant, and this silicon sealant was imported since it was not available in India. After the anchor fastener is placed, it was sealed with the epoxy sealing outside so that no water is transferred even after accidentally leaked from the seal joint of the marble. The standalone marble were having 8 to 10 mm gap between each other, which were sealed with the again silicon sealant, putting the molded rubber cordon behind it. For this 10,000 square meter of the white marble which is fixed outside, we find that around 40,000 holes were drilled in the concrete. Can we go to the next slide? Very important. Can we come back, please? Please, I just missed in my presentation. All these works of the alignment, fixing, and that were just not possible with the masons who came from Rajasthan. Even the experts from France were not able to guide the masons to get it done. Ultimately, we use the carpenters to do those jobs, since they have to understand the alignment, use the step template and the curve template, which were well versed and well evolved, and they understand the while masons were not able to comprehend the gap and dry fixed cladding with tolerance of 1 mm. They always used to talk in suit, what we call the quarter as a suit. Can we go to the next slide now? There were innumerable trial and mock-ups done at the site. The very important one of the full representation which I want to cover here is for the interior dome. Before this mock-up is done, the shell thickness was 50 mm for the interior dome. A full escape representation is made, and it was found that it is a very serious problem of doing the uniting in that area. So it was converted into 60 mm in situ construction. There were challenges of fixing of formwork, reinforcement, and concreting, which were solved by making the proper method statement and message in advance to be slide there. Can we go to the next slide? Quality assurance. Actually, from the beginning to now, I had been talking only the quality. For every stage of the construction, there's a mock-up, there's a trials, there are the tests, and for every activity, there used to be a work statement, detailed method statement. And there was an acceptance criteria, what stage that will be really accepted. Of course, that was always used to be the zero tolerance acceptance. A detailed checklist was prepared for various hold points, so that no work is repeated or go waste. All training, experience, and understanding occurred in our mock-ups and the detailed representation. A full-fledged concrete laboratory was available at site, and there was very strict quality control even while making of concrete and placing of concrete. Can we go to the next slide? Next slide, please. Can you go to the next slide, please? The skill development as such was required for all of us, for the carpenters, foremen, engineers to work to produce such a high quality construction. We used to call that it used to take 2 to 3 months for the new person who comes to the site to understand what is the acceptance criteria of the quality in this site, whether it is an engineer, whether it is a foreman, or it is a carpenter. It takes a hell of the time to comprehend and start doing the desired quality. We used to a carpenter within a month or two training, we are able to fix the formwork and marbles with the required accuracy. Actually, marble job we completed 2 months ahead of the schedule. Can we go to the next slide? Yeah, challenges. The challenges were right from the design, engineering drawing, the use form, splitting them into the small pieces and workable pieces, skilled manforce, availability of them and training of them, and making the quality concrete, quality control at every stage, and the time management. Very important thing which we have to comprehend when you do such a large shell structure with all the steel support and the timber, they move in a different way under the extreme temperature variation of Delhi or any city where the work is carried out. So right from the first decking to the completion of the concreting used to be very strict time schedule. If the 3 weeks or 4 weeks plan is made, it has to be completed in 3 weeks. If you leave it, the shell will start getting distorted and you will lose the control of the shape. So it was a really great time management for every activity. It is to be done in a military-like instructions, and all in the budget cost and the part to be a team management, to be passionate and to work as a team together, taking the hell of support from one to another. I used to have a pocket in my paper in my pocket, having 8 activities to be carried out for tomorrow, and the person whose help I need to get it done. So I will be first running from one person to another person who will allocate his time, since the work has to be done by so many experts coming and producing and making this making of this Lotus Temple possible. The imprint of that learning is still with me, and that really helped me when I was asked to make the presentation by Mr. Gadgil, Mr. Ganguly, and Mr. Prasad. Management learning will be very properly covered by maybe later on in our discussion, though the passion, the team spirit, micro planning, what we learned from there helped me as an individual, not only the company L&T, to take up the complex structure one after another. Actually, there are the cases when I went to my client and explained the way we executed this job, any complex structure will quickly come to my pocket and I will be able to win that contract. Thank you very much for giving me this opportunity, sharing my thought process, and thank you all ICI. Thank you, Mr. Prasad. Thank you, the participant, for listening me. Maybe if some part I have overspoken or underspoken, it was just because of scarcity of time and the betrayal of the memory for a work carried out 40 years back. Thank you.
Thank you, Mr. Seth, for a very, very lucid presentation. And I am sure in a time allocated to you, you have done best part of the time management. You have made it look so simple. The extreme complex structure, you have made it to look so simple that people probably will mistake that it was as easy to be done as you have spoken. You have covered almost all the stages of construction, especially the complex structures, the superstructure. But I am sure it was not that easy. And that is exactly what I want to bring it out of Mr. Ganguly during my small deliberation with him now. And I would like to add one more thing here. We are very, very fortunate. All of us, we are extremely fortunate to have Mr. S. Naroy of ECC Construction amongst us attending this webinar from Australia. Mr. S. Naroy, I can call him the father of project management or planning in L&T Construction or ECC known at that time. Presently, he is in Australia with his daughter. And when Mr. Ganguly and myself contacted him and requested him to be there, so he said that yes, he would like to do very much. But because of his health condition, he says, I will be there, but I will not be able to speak or share anything with him. But I will tell you that all of us should really thank Mr. Naroy for his foresight at that time. We even today call him father of planning in construction, especially in L&T construction. So, Mr. Naroy, thank you very much for being with us, for extending your best wishes for this webinar. And I would like to compliment and congratulate for all your efforts 40 years down back in the memory lane, because you have done some enormous work and is as in civil engineering, which unfortunately is not seen in the superstructure because you were there in the foundation and mostly at Chennai. The most complicated technical analytical geometry work you had done, and you were really the backbone of this project as whole project manager. Of course, we did not have those titles that time, but he was the whole and soul in charge of this project, governing, guiding, and actually giving assistance from technical point of view. Thank you, Mr. Naroy, to be with us. Now I'll come back and I will come to Mr. Ganguly. Mr. Ganguly, it is going to be really a journey through the memory lanes. And I'm sure you will like that. As earlier mentioned, you are very, very passionate about the construction as such. And Bahai Temple is no exception. Before we go, I would like to one simple question to you. I am seeing a lot of white hair on your head now. How many of that you got on Bahai Temple working under those exacting environment?
Actually, if you really ask me, I didn't see any white hair at that time. But later on, much later, I think it was somewhere in the 90s, that all of a sudden I found a brown patch on my skull and I saw, hey, I'm getting bald. So that was age taking over. But really speaking, Bahai did not give me white hair.
Okay, thank you. That's your courage and passion. Now I'll come back to the very, very basic of this thing, as I understand. Mr. Sabha, about whom we talked. And I was told, and people should really understand that he had worked on this project, single project, for more than 10 years without drawing any single line on the drawing board for any other project. That is the kind of dedication he has shown in the professional life of an architect. I just want to understand, because you have dealt with him during the construction as well as afterwards, what must have been his basic philosophy? Right from concept to detailing to exacting specification, what was his mindset about that?
See, he was the main architect. This was his concept, the Lotus. It was approved by their headquarters, the Universal House of Justice. And Baha'is, as you know, they have built such temples all over the world, all unique by themselves, with some speciality or the other. So his philosophy would have been very similar, of creating a very unique structure, but keeping in mind the architectural trends of this country and trying to build it more with people than with machines. He also had something in mind which he's called was to have minimum maintenance of the building for the future. He would not allow any plastering to be done, any painting to be done. So it has to be in its raw state as concrete. And that would have been his philosophy, but I couldn't really, although I have dealt with him very closely, at one stage when I entered this project in middle of 83, September of 83, all seemed to have been lost and we were struggling to get it restarted. That's the time when Mr. Naharoy was given the charge, and for some reason or the other, Mr. Naharoy picked me. I don't know really what reason it was, but I had worked with Mr. Naharoy on the Damanjodi project initially in the planning stages, and probably that was the reason why he selected me, and I was there. I was very fortunate, really speaking, because almost 3.5 years of the project was already done. A lot of learning had already taken place. The geometry problems were almost resolved. Only the nitty-gritties were left. And the beautiful arches that you see were already in place, which would take the main superstructure. We had a group of people who were almost determined to prove a point that it could be done. There was no looking back. There was absolutely no looking back. And that's the point when I came in. And it was like any other project, you're given a task, you have to do it. And therefore, you set about working on it little by little, and try to move on. With Sabah, it was not that easy. Just with Mr. Sabah, it was not that easy because the period just previous to that was not very smooth. It was tough. But we knew that we knew that we had to go along with him for some time to understand him and not start resisting from day one as to what he would be wanting. And I think that paid off a lot. The trust building started happening. He started believing in us that yes, we were serious. We wanted to do the job. We have our difficulties. And he started appreciating those difficulties. And the two teams, that is our team and Saba's team, started working together, as it were, to find solutions, to find ways out to do the job, whether it was mock-up, whether it was trials, whatever it was. And very frankly, I had visited this project first time in 1983, 82, when Mr. R. Balasubramaniam was the project construction manager. The arches were under construction, and I had just a passing remark made that this is a unique opportunity, a lifetime opportunity to do a construction. That sort of stuck on, and when Mr. Naharoy asked me to take up this job, I was reminded of it. Yes, I have this opportunity, which I myself said that it's a lifetime opportunity. And that's how that formed the basis of the approach that we had to resume the project, to proceed with the project, in spite of all the difficulties, the bottlenecks, the shortcomings that we had. But I must say that we had a brilliant team in place right from the beginning. Young engineers keen to prove a point that we can do it. And that's how it worked. And little by little, the trust got built up, and we started working as a team, Saba's team and our construction team. Of course, Mr. Naharoy was a great catalyst in this whole process.
Mr. Ganguly.
Just a moment, please.
Yeah, you can switch it off. Here I would like to call you a poet. And people must be wondering why I'm calling Mr. Ganguly poet, who is a hardcore construction man. Because you have really created a poetry in concrete. That is how it is depicted, that poetry in concrete. And at the same time, I would like to tell you that you are lucky to be in 20th century to work on Taj Mahal of 20th century. The reason I am telling you why you are lucky, because I was told, of course it may be a myth, when real Taj Mahal was built during those days, the hands of the people who worked there were cut. So you are working on a 20th century Taj Mahal, and that is how it is also known, apart from Bahai Temple. So a great poetry in concrete we are able to see today. And I would like to take you to the next level. That did you know really, and I'll tell you when you said about your 1982 visit, that you are one of those persons who ask that question or who do not ask that question, why me? I know that you always ask that question, why not me? And that probably drives your passion in construction. And that is the reason I say that, did you know at that time that you will be working on a monumental or an iconic project? Because by that time you must have worked on many number of commercial projects. And this project was quite different to be a monumental and iconic structure. Why I'm asking you that question also, I'll tell you, because it needs a different set of mindset when person work on a monumental project. Did you prepare for that?
Yeah, one would naturally think that yes, if you look at the model of the temple, you would automatically sort of think that yes, it is a monument that we are building. But we, construction people, probably don't look so far. So when we took up this job, already, as I said, about 3.5 years had been spent. A lot of work had been done, and very good work was done. Very good work. The grey concrete that has been done in the basement and in the arches were super concrete. So if you look at that, even after looking at that, one still remained in a small sphere to say, yes, I have got a task in hand, I have to do it. And so were all my colleagues, that yes, we have to get going and we have to build this. Actually, I have to admit, we never thought of it as a monument to start with. But as the building started taking shape, people started telling, what's this? This is something unique. And that's the time it dawned that, Arey, we are doing something different. And then when you add up the little things that we did, put it together, and then look at it, and we find, oh, we have done this. And that's where it dawns on you. Actually, others tell you more, that yes, something is taking shape, something is getting built. And when the first concrete was deshuttered, first white concrete was deshuttered, and we were all standing there, that's the time when we knew that yes, we are in it, we are there, we know what we are doing. And this went on and on and on for various items of work. And every day, as you know, was something new, some new problem, some new solution. People like Bhaskar Raju, A.L. Shekhar, David Raj, S.N. Seth, Daljit Singh, Avtar Singh, the entire team, and many, many more, were all sort of charged up to create this. So really speaking, we didn't start off thinking we are building a monument. We started off thinking that we've got a difficult job in hand. We have had some not so good experience in the past. We have to overcome all that. And from part to whole is what we started building. And finally, yes, we realized some way through that we were building a monument.
You are rightly said that when you went there, quite a work of, I would say, underground works and other works were completed, which normally are not seen by many of the people. And whenever people talk about the Bahai temple, it is generally the lotus what we see in superstructure. But I can vouch, and what you said is that even every corner, every square inch of the project, wherever you go, has been done very, very meticulously and meeting the same standards of quality, whether it is substructure or superstructure. That I really appreciate, whether it was grey concrete or any other concrete, or even the minutest of the minute part of this project. And that is really the hallmark of this project. It is not only the public area or people who go there, that is done in excellent way, and other areas like we see in today's projects, they are neglected. So that is really a hallmark of this project. Now going forward, I mentioned in the beginning also, and in between Mr. Seth also mentioned, that what was given to the project people to start with. Of course, those of the people are not with us now, either because of the age or some people are not even with us. They must have gone through that. You say that most of the technical problems were solved. But I was told that Chennai IIT, of course the Madras IIT then known, did monumental technical work to convert basic concept to understandable technical details of geometric forms. The geometric forms were so complex, and probably many of us we would remember our engineering drawing lessons when we are in engineering colleges, that intersections of cylinders, spheres, toroids, cones, and we must have been struggling with our set squares to draw those curves. And now here it was a challenge to convert that, and drawings I am sure were available, they were not dimensional drawings. Probably you had only diameters, the heights, and some quadratic equations. And then to convert that mathematical formula or formulae into actually understandable geometry must have been a task. And like Mr. Seth mentioned, that we did not have all those AutoCADs and super computers and other things. And monumental work was done definitely by IIT Chennai. And they must have converted tons of documents at that time. But even to convert these tons of document into understandable geometry, it must have been quite a task. And also to translate and communicate that to people at site. So what were the efforts and what was that experience?
Yes, it was a Herculean task, because what IIT produced was coordinates of the structures, top, bottom, at certain intervals. You had your XYZs available. But to select from that and transfer it onto the ground was done by, as Mr. Seth explained, through small whatever hand computation was available, broken down. It took long time to understand, and that is how the coordinates required for setting out was arrived at from the huge pile of coordinates that was available with us from IIT. It was the entire young team that worked continuously to be able to sort this out and hand it over to the people at site to really lay out. As a matter of fact, Mr. Seth mentioned himself that he was there at the setting out. So it was engineers really setting out, and not really surveyors or anything like that. It was engineers doing the work. And we were fortunate at that time to have a bunch of young GETs, Ramachandran, Kushmakar Rao, and people like them who could understand the complexities and translate from what we got from IIT and convert into whether it was reinforcement, whether it was shuttering, whether it was just layout on the ground. So it happened in stages. It happened in small stages, small learnings. We got stuck at times to even comprehend as to whether this would be a straight line or whether it would be a curve. And we had to look into mock-ups again and understand that if you have to get this surface, final surface, you need to do this. And this is how probably it got proven into the back into the coordinates. So it was a good bit of back and forth from what we got from IIT, setting it out on the ground, checking back with IIT, and then resolving ourselves and finally getting the approval from the architect that yes, this is how you proceed.
Now, why I ask you this question also is quite relevant to today's thing or debate going on in the country, that mathematics is not required for engineers and it can be removed from their syllabus. That is one topic going on. So do you, I don't know whether they are defining the engineer skills, but do you think that you were able to do this project, or you would have been able to do the projects with engineers who did not have mathematical knowledge?
You see, you can, if someone gives you a drawing, and if you can understand a drawing, you can do a construction. You can break it up into constructible elements and start doing it. But here it was not the case. You are not given a dimension drawing. So you were given curves, you are given edge lines with coordinates. So you had to sort of understand that if I plot all these coordinates, what do I get? Finally, what do I get? And whether that is right, whether that is what the architect wants. There was huge debates on the edge lines, the boundary lines of the various leaves, but it got resolved through sort of mutual understanding of the subject. It may not have been that we needed very high professional mathematicians, but a comprehension of solid geometry, of planes cutting spheres, cylinders cutting spheres, all that, to understand it. And we had some very brilliant people like A.L. Shekhar, primarily S.N. Seth and others, who really applied their minds in solving these things. It was little by little by little by little, and through mock-ups. You do it, you understand it, try to put it as a mock-up, and from the mock-up you try to get back into the drawing or whatever data you have.
Now,
So
I'll
that
take
was,
it to forward. Yeah, go ahead.
and as far another thing was, I think IIT helped us in analyzing the space frame structure of the interior dome and the inner leaf shuttering, the staging. So this was a space frame structure which had to be analyzed, and I think IIT contributed to that as well.
Now, coming back or coming forward, actually, which I have mentioned it to you, during the project when it was conceived and then awarded to us, L&T Construction, many advanced technologies as we see today and modern equipments and tools were not available. While describing the challenges, Mr. Seth has enumerated them very briefly, like I told you, to make it look very simple. But I am sure that every small detailing must have really posed a great problem. And what were special significant challenges you faced and how did you overcome it? Just to give you an example, just to have a specification that no cover blocks will be used in anywhere with white concrete. Simply said, but I am sure very, very difficult to achieve, especially in a thin shell with congested reinforcement and tolerances of almost 0 millimeter. How did you overcome such things? Mr. Seth has said that yes, challenges and all the things, but I'm sure every one of that, even vibrator needle, how to get a vibrator needle in every nook and corner.
Agreed. These are all challenges every day we are facing. But once you make up your mind that you have to do it this way, that cover blocks will not be allowed on the exposed face of the concrete. Once that mind is made up, then you start looking at solutions. And fortunately for us, we had such people who are always looking at solutions. Bhaskar Raju, again A.L. Shekhar, S.N. Seth, all the people there. They were looking for solutions. And we did find solutions. Maybe sometimes the Sabah's team, they also chipped in. Particularly Mr. Ashraf, Kamal, they also chipped in at the later stages to solve problems. They raised the problems, they solved the problems. So it happened like that, that problems were there, problems were solved. we didn't really get stuck up on any count. We didn't get stuck up. We could find solutions at site. That was the team that was available to get these solutions, and that was our strength. A simple hook to lift the reinforcement up and tie it with the top shutter, the top frame. Galvanize this hook because this remains back in the concrete. And you take the top part out, which comes out, and you seal that hole. That was all. So that you could maintain the cover within what set says between 30 millimeter and 34 millimeter. You cannot go below 30 millimeter. And there was a method for checking that. There used to be a fishing block which used to be lowered from the top and swung around. If it moves freely, that means you have the clearance. If it gets stuck anywhere, means you have a problem there. And then you rectify it again and you make it proper. So that was, we learned, we practiced, and we did it. That's all.
Mr. Seth also mentioned about a teamwork. You also mentioned about a teamwork, and especially when this kind of problems are there, like I mentioned, human spirit of innovation. But I remember one story which you used to tell about getting those air bubbles in your balustrades, and from where you got that suggestion. It was amazing. Can you just tell that?
Yeah, we made a battery of 2 castings in one mold. It was made with steel base and timber with teak wood beading and all that, grooves for the grooves and all that. So moment you cast vertical, you land up with a lot of air bubbles because it's a thin section. Whatever you vibrate, you do with mold vibrator, you do with needle vibrator, whatever you do. So I think it, who raised this, whether it was Gyani ji or Avtar Singh or someone, that why do you have to make it vertical? Why don't you just incline it and keep the exposed face at the bottom and then cast it? Okay, top face you're going to get some bubbles, but the bottom face will be clean, which is the exposed face. And that is how we solved that problem, that we got a very good bottom face without air bubbles. Top face did have some air bubbles because it was inclined like that, but it solved the problem. Such things kept happening all the time.
That clearly tells that many people talk about that construction being a science of common sense. And that probably tells the truth. That suggestions for complicated projects are suggestions for complicated. Yeah, please go.
But I also would like to add that although it is common sense, there is at some scale there is some specialization in construction. It is engineers have to specialize in construction and remain in construction to make construction worth it, and not leave it to just anybody to do some construction. Then you don't get what you want. So
no, that very clearly says that complex problems can also, the suggestions can come from people who are got experience, and construction really thrived those days, I would say. Those days we also, you will agree that we learned our practical engineering or really the site engineering from our foremen who were much more hands-on experience, and their skills were developed with hands-on. So I think you hope.
And I think, you know, when you're all working as a team, and everyone is looking into everyone else's problem. It is not my problem, it's not his problem. Then it becomes easier to get on and resolve, because a lot of minds have started working. It's not mechanically doing things. It's your mind which is also doing work all the time to be able to resolve issues and go ahead. So altogether, it was an extremely high level of teamwork, both within our group as well as with Saba's group, that made this construction happen.
No, that is exactly what I asked you. That okay, top leadership is talking about monumental construction, precision, and other things. But you have people at different levels going down to the last craftsman, and to get that mindset converted for that kind of work or expected quality work, it must have been a challenge by itself, because it requires huge amount of human efforts to convert that mindset and bring them onto the same platform of your thinking. So how was that, difficult or easy?
You see, I'll be very frank with you. I really did not have to do that.
Were you going around with Danda?
2.5 to 3 years of hammering had been done. We were all in a state of some amount of hesitation, whether we will be able to complete, whether we'll be able to take up and complete this work. The moment it was decided that yes, we are going to do it, the challenge sort of percolated down to the last man. So we did not have to really do much to say to boost up the morale of people. They knew that they had a tough job at hand. It is not going to be easy. It's going to be very trying, but we have to be at it and get it done. That's all. And that's how it worked. We didn't have to give any lectures to anybody. We did not do any toolbox meeting, nothing. It was each one on his own with a very high level of dedication right from day one as soon as the work started. I think the puja was held on 16th of January 1984 for restarting the work. And thereafter there was, of course, the initial period was quite difficult for the first 3-4 months because we were struggling to get the structure back to shape. The structure was there for about almost a year. Getting that to shape, we had a little bit of interpersonal problems up and down. We had some very big stalwarts who were there. So naturally, with so many stalwarts, you have problem. But then little by little, things got ironed out. And once the first white concrete was done, that was on 24th of May, 1984, then there was no looking back.
I'm sure for L&T construction, this must have been a very good breeding ground for construction, good quality construction engineers to produce. All the names what you mentioned there, of course, few of them, there are many of them. Bhaskar Raju is there,
many of them.
David Raj is there, many of them there. Seth was there. Vildi was there at the forum.
So many of them. Last few days I've been trying to recall quite a few of these incidents that happened, and it was there was not a stage where we got really bogged down with anything. Yes, problem was there, problem had to be solved, but we were not bogged down with anything.
Now coming to the fundamentals of the project, actually, I would like to ask a very pertinent question. That time, of course, the people were not talking about the project management of so much. Modern project management. Probably we were more worried about the, okay, quality management, yes, time management, yes, cost management to some extent. I don't know how much safety was being talked those days. I'm going back to those 1980s and all the things. Indian construction ethos on safety probably we will not talk so much as we talk today. But what was the basic philosophy? Just 1 second. What is the basic philosophy of project construction in terms of proactive macro planning, micro planning, mock-ups, construction method planning, and execution to achieve excellence? I'm just giving a broad spectrum of project management, what people talk about, right from macro planning to going to the exacting.
You know, I will again go back to the first part where a lot of learning had already happened. A lot of data was available. So when I got into the project in September of '83, I had about 4 months to work with the people there on the network, the PERT network, detailed PERT network, resources, both manpower resources, staff, as well as materials, and the costing. The costing was very important because we were to put up a claim to the client, and we wanted a reimbursement of certain amounts before we could restart. So there was a very detailed exercise done over a period of about 3 to 4 months. Very detailed. And you can say that this formed the basis of our construction planning for the execution stage. You can say that this is a tender which was redone with a lot of actual site data. A lot of mockups were already done. So from there, we moved on to the next one, extrapolating from there. And then coming to that final figure on the budget that we need this much more money to be able to complete the work. Hello. So we were fully prepared when we got onto the job, what we had to do for the first 3 months, the next 3 months, and the next 3 months. These were further converted into micro planning, detailed planning, and all that stuff. And you know, with Mr. Naharoy, it was reviewed very practically in a very pragmatic manner. And we knew that we had to do it on time if we had to be within the cost that we had projected. And I can't say that someone else made the tender because I was myself there along with the site team. So it was done at site, approved by the management. The AR was also involved in that. Mr. Naharoy was involved in that. And finally, we got what we wanted and did the work. Day-to-day planning was always there. Reviews, not in very detailed meetings, because everyone was talking to everyone. And therefore, there was no structured weekly review, monthly review, and all that stuff going on. Reports were being submitted to the client. Reports were being submitted to headquarters to Mr. Naharoy. And it had become almost like a routine that site review, site planning was key for the site, which became a report for the other people, like the client or our own management. We didn't really have to discuss separately on this. Of course, Mr. Naharoy used to visit the site once in a month or twice in a month, and it used to be reviewed once all over again. Yes, I remember we wanted to optimize the use of staging, I think for the outer leaf, and we wanted to change the sequence a little bit, the sequence which was mentioned by Mr. Seth. So we had to go back to flint and needle to do a recalculation. And I still remember that we had to pay something like 12,000 pounds to get that recalculation done. I think we saved some time for that. But it was, very dynamic. It was dynamic.
No, I was told continuously by Mr. Seth, as well as you were also mentioning, mock-ups, mock-ups, and mock-ups. How much was the emphasis, and did it really help you?
That became a part of our learning. Without that, we couldn't go to the next stage. Once, without your mock-up getting cleared, you can't go to the main construction. So it is your job to start the mock-up well before time. Say your interior dome would start 6 months down the line. So Shankar Lingam came with his drawings and started making a mock-up for the interior dome. And in that 6 months, all the problems were resolved and work went on to the site. So you had to allow that time to happen, and that was part of the planning. Now, bush hammering, how many trials we would have made? Because he was not satisfied. You can't use machines, it goes too deep, you have to make it less. And with that, finally, we came to Desi, a small hammer and a chisel. And we started making small hammers and chisels. People used to get trained at site on the mock-up kiya tha concrete ka. We did trials on that, and then they were sent to the site after it is approved. So it was a continuous process of this type that went on. Mock-up first, approval, then you go to the site.
Was the mock-ups used also for training of the people?
Of course, of course. Whether it was shuttering, whether it was concreting, whether it was bush hammering, whether it was balustrade casting, everything, it was done. You won't believe me, the marble fixing was not getting started because we didn't want to handle the marble, because we knew that they were very precious. They've come all the way from Italy and all that stuff. Each one is numbered. So we made marble panels out of timber and started fixing them on the leaf to understand the fixing of clamps and all that, how the gaps are going to form, how the template is going to fall, how the curvature is going to be maintained. Of course, we didn't make curved panels. Our panels were straight, but we could understand. So after all that was sorted out and we knew where to drill, how to drill, where and all that, that we went to we took the real marble and started doing the work. This itself took almost about 3 to 4 months before we got onto the real marble fixing. But once we got onto the marble fixing, it just flew. It became so easy. It became very easy.
Now I'll take you to a very particular difficulty or challenging situation. See, I understand that all geometry was very critical, and inner formwork, inner shuttering making was very meticulously done with all the templates and all the things. But I believe that it did not have that exacting time requirement as probably it was for the outer shuttering, because outer shuttering was related to your placement of the concrete. Mr. Seth mentioned about a military-like time precision, because to avoid the core joints, so a particular level of concrete has been done, and then you can't place that shutter beforehand, because then there will be a problem of vibrations and other things.
Putting the concrete, yes.
Also, people approach and other things. So outer shutter placement must have been really an Herculean task. So what was the planning? What was the execution? How the people were? And I'm sure, because that is actually what is giving you the beauty of that white concrete.
You see, first of all, you had the on the framework, outer framework, you had a shaped timber, which defined the geometry. So now your shutters, which will you just slide it down on the shaped timber and just wedge it. There's nothing more than that. Now we did a trial fixing of all the outer shutter, right from bottom to top. Say the outer leaf complete, trial fixing was done, numbering was done, and they were kept at the site of the platform. So you knew, the carpenters knew that once the level of concrete was reached, they had to rush in and put that shutter at the right place, wedge it, and that's all. Obviously, in that hurry, you cannot get 100% alignment. You will have a little up and down. It will happen. However, where you try to do it, they try to do it as best as they could. But it didn't really matter because there was a gap of almost about 40 millimeters between the marble and the outer surface of concrete. So it didn't really affect anything as long as the shape was achieved. The concrete quality was good. The concrete was well vibrated. The vibration was not compromised, so the strength of concrete was good. Durability was good. A little upset here and there wouldn't matter. We tried to keep it to a minimum. But we got used to this system because that it was done in all the leaves. Even in the dome, it was done like that. The outer shutter was done because without outer shutter, you can't vibrate the concrete. So it worked. It worked quite well, I would think.
Now,
Sir,
please,
one minute,
please come.
I will try to supplement one more time limit. It's not only the outer shutter, including inner shutter used to be a big problem. From frame to plywood, if you leave it more than 3 to 4 days, it will start losing the shape.
Warping. It will have warping.
You have to align it at the frame level, keep it, and the moment alignment is over, you've got a limit of a day or two to cover it with the plywood and again align it. So there also military was there. Military-like action was there. If you leave it for more than 1 day or 2 days, you will start seeing the light in the template and surface will not be accepted. So it was at every stage of the construction, you will find that whether it is an inner formwork, whether it is a roof formwork, whether it is a shell formwork, everywhere, if you start an activity, it has to be completed in time. Otherwise, ambient will spoil it. Thank you, sir.
The other challenge I will come to you, because these are practical problems faced by many people even today, especially on the thin elements, be it vertical or inclined or whatever is there. Especially when there are both side shutters are there. The cleaning inside the form. It is not only that compressed air can clean everything, because there are a lot of debris which goes in while we are working. Either it is metallic, whether it is timber. So how that was managed, because otherwise it will go there and it will immediately be seen on the surface. And I am sure that would have been a disaster.
Yes, I think good you raised this issue. I'll just give you a little statistic on this. You know, for the outer leaf particularly, I remember the cleaning operation, the checking would be over in the previous evening. The checking is over, reinforcements are checked, outer trial fixing is over. Cleaning would start, our people would be doing it in the night shift and all that. The client's engineer would come at 4 o'clock in the morning. A final wash will take place from the top to the bottom. The bottom will be cleared up completely. Not one speck of timber or wire or anything lying. Finally, a magnet will be used to remove those pieces of wire, to clean the surface, expose it completely properly, and then morning 8 o'clock. So from 4 o'clock in the morning to 8 o'clock in the morning, all this has been done. 8 o'clock, you get the clearance that concrete can start. So your first shuttering will be placed in position, and then the concrete starts.
Now
So
I
this
will come to concrete also. I will
this
come to
used to be,
concrete also. Yeah, go ahead, go ahead.
it used to
Go
be
ahead.
very, very. Yeah.
Now I will come to the concrete.
Ah,
Because technology, the tools, the equipment available that time, I'm sure you did not have pumps, conveyors, or batching plants even then. You must have had only 10x7 mixers. And you wanted a fair face concrete, that also bush hammered. So homogeneity of the concrete mixes must have been on top priority. Because I know that if the mix is not homogeneous across the section, and then you do the bush hammering, then what results you can get? Some places you can see only sand, some places you can see only aggregate. So first is how that was controlled. Mr. Seth mentioned about the weight, what was considered, including the rate of pour. So what was the rate of pour you were achieving at that time for every pour?
I think it was something like 40 centimeters per hour or something, 45 centimeters per hour.
45 centimeter per hour.
I will tell you the outer leaf.
Three layers of 150.
See, the outer leaf, the total concrete, I still remember, I've been trying to recollect, was something like 54 cubic meters of concrete only. 54 cubic meters of concrete, and we did it over 48 hours.
Oh.
So
Now that too again, so much of time without having cold joints, that's a really cold joint.
That is how it went, and how the vibrators used to be put in from the top. And you used to have a group of people on the top platform operating the vibrators, and the shuttering people at the bottom to fix the shutter, and the concrete people after the shuttering has been fixed. Now you were talking about the homogeneous nature of the concrete. Our aggregates were divided into 4 sizes. 20 mm down aggregates were divided in pins with 4 sizes. Sand was in 2 sizes, the silica sand. So the mix used to be, although manually done with weigh batchers, although manually done, it was every batch was supervised. We used to have our good old Mr. Menon, who used to be there sitting on every batch of concrete mixed. And that's how it worked. Now, today you can say, yes, we could have a small batching plant. But you see, the rate of concrete is so slow, and you could have a concrete pump, but it would be a different experience to think on those lines.
That reminds me, you mentioned about Mr. Menon, who was your concrete technologist. But I would like to just share with our viewers what different compliments or what different qualities we had with people. Mr. Menon, in his professional career, he was a concrete technologist and batching plant, looking after batching plants and all the things. But you will be surprised to know that in his free time, he used to write script for the Tamil movies with the stories from Karunanidhi. And his screen name was Appan Thatchet. I still remember, because he used to tell us those Tamil movie stories whenever we used to meet him at site. That is the kind
He wrote
of
songs also. He wrote full of the queue of the songs.
Yeah, he was a poet. He was a great poet there. So that's what
Right.
I was telling. That is how you could make that concrete poetry in concrete. So now coming to a very pertinent question, Mr. Ganguly. If same project is to be executed today with the same exacting specifications, what will be the different challenges you feel that today's people will face than what you faced?
You see, first and foremost, your understanding of the geometry, the getting of the resolving the coordinates and all that would become very, very simple with AutoCAD, and that part would be wouldn't definitely take so long. Understanding of the structure as it is, with whatever information is provided to us. When you move on to staging, formwork, you can have different materials for the lining and all that stuff. Today, all sorts of materials are available which can produce very high class finish in concrete as well. So you could look into something like that. But I don't think one would, it'll depend a lot on the architect, whether he would like to shift from in situ to precast. Now, the whole concept of having this done in situ was Mr. Saba's idea, that yes, I want something like this, not the Sydney Opera House, which is precast panels on ribbed structures. So he wanted it this way, and therefore if you remain with this, there's not much that you can do with the staging, the formwork and things like that. I don't know, in lieu of the top shutter, can you think of something else? Nowadays you've got very different additives for concrete, where you can do high head concrete with shutters fixed all along. Pump the concrete from bottom. You could look into alternatives of that type. Like, you know, you have in underground structures, you sometimes pump the concrete from bottom to top. So you may do it in lifts of that type with proper joints and things like that, without affecting the aesthetics. The finishing, whether it is marble, whether it is anything else, it depends. If you use the same marble, you have this. This was a very efficient system of fixing the marble. Of course, we had problem. The client had problem with the silicon that was used in the first case. It had to be completely replaced and redone because it penetrated into the marble and attracted a lot of dust around the joint, around that gap. So it was looking very odd, and later on I think they removed the silicon sealant and redid the sealant work. So otherwise what else can you think of? Maybe a lot of hand tools would be used which are available now for doing it faster. I'm sure things can be thought of to expedite the construction work, expedite the form work and things like that. I'm sure a lot of options can be looked into with new materials. But we would be most familiar with what we have done. You know, go on the beaten track. This question was asked once, that how else would you think of building it now? If you were to build it, would you do it differently? How differently would you do it? Really, one has to give serious thought with whatever you really have to do to think about it. You can't think of an hypothetical solution to this. But I'm sure construction has advanced a lot. a lot of things can be done differently, keeping the overall finished product to be the same.
I think
Yes,
Gadgil sir had lost the connection.
No issue, sir. Meanwhile, we have actually lot of questions. I'm flooded with questions and compliments, sir. I will just take few of the questions from the
okay.
audiences. Yeah, to start with the first question, I'll start with Mr. Hemant Joshi's question, and I'll club a few more questions with it. So he's asking, at the time of like project tendering, whether L&T was able to anticipate, or up to what degree they were able to anticipate the requirements of project, and how much change it was and how it was handled, and also how was what was the life of the structure planned and design and like executing, how it was done. Yes, sir.
I'll tell you a story on this. I'll tell you a story on this. You know, I was not in Delhi at that time. I was probably in Calcutta, and we heard that we have been awarded this job of a Bahai Temple. Our competitor was Gammons, and we were awarded this job, and we've got very good prices. What was the good price that we got? Oh, our shuttering rate is 250 rupees a square meter. Those days, the rate for normal form finished shuttering used to be, I think, close to about 50 rupees a square meter, 40 or 50 rupees. So we got 250 rupees. So it was good, isn't it? Good rate. You know how much we ended up? I still remember because I used to be involved in the costing. 750 rupees. We spent 750 rupees per square meter. So
At that time.
that was our knowledge. You know, this client was very, very, very open, very transparent. In the tender, there was a question which we had to fill in as to how much of temporary steelwork would you use in this structure. So I think if I remember right, and I have not seen it myself, I may be not absolutely correct, but this is what I've heard, that we put in our first tender filling, it was 250 tons. So the client was not very happy with that. He said, no, please have a relook as to what you filled in. And then we raised it to 500 tons. I don't know how much we increased the price, must have increased the price to put that another 250 tons of steel, temporary steel. And then finally we ended up spending 1,250 tons of temporary. So that is what you know. And such structures, I really believe, and I have been associated with a lot of difficult structures, first time structures, and getting a right price is quite difficult. Even if it's an item rate tender, it's not a lump sum tender. It is very difficult.
I'm sorry, there was a technical problem.
We keep making these mistakes and we start getting jobs. And like it or not, we start doing jobs also.
I'm sorry, I was cut out in between because of the technical snag. Like I said, I almost come to my end of passion because deliberation. We can go on and on, but I would like to also have some time for the organizer for questions and answers. And I am sure Mr. Ganguly can talk with same passion not only about Bahai Temple or Bahai House of Worship, but many projects that he had done. And probably it will be a good idea to have some webinars like this, especially on cable stay bridges. I distinctly remember one cable stay bridge, we did it in Jordan. What do you say, Mr. Ganguly? How will be that experience?
That is almost equivalent to this. Bahai temples.
See, why I'm telling you, because normally cable stay bridges are done. Normally cable bridges are cable stay bridges are done on a straight alignment. This particular bridge, what I am talking about, is a reverse S. And of course, the story goes about the same exactness, same Newton's third law, and I'm sure it will be a great experience. So I will now conclude our deliberation here, and I'll ask Sucheta to take over and take you through some questions answers if she has already gathered, and she can directly pose the questions to whom so you intend that questions to be answered. And thank you very much for all the people. Thank you, Mr. Ganguly, for patiently listening to my real poking questions. And we look forward to have similar experiences. And thank you very much. Over to Suchita.
Thank you,
Thank
sir.
you, Gadgil sir. As you suggested, we request Ganguly sir to kindly give some time for that cable state bridge also. Whatever the convenient time with him, definitely we would like to hear you, sir. Thank you.
So, yes, sir, you can
So
continue.
to continue replying that question just a little bit more, after working for 2.5 years, 3 years, we got a lot of data. Based on that, we could extrapolate and have a completion cost for the project, which was reasonably accurate, but because we had that data. Now, normally when you do a tender, because the question that was asked was, how accurately could you assess the work? That was the accuracy of our assessment. And naturally, people who make tenders, they don't have all the information or all the methods or all the complications that a complicated job like this will require. So they make some assumptions. Assumptions, you can make it on the plus side, your tender will be very high. You can make it on the minus side, your tender will be low. So it is the experience of the tenderer, how he goes about. It's difficult.
Okay. Thank you, sir. So next question I'm combining 2 or 3 questions. So it is about like you and Seth sir both have you have emphasized on the time management part, the budget part, and the quality part. So combining all the 3 aspects. So some people have this feeling that when it is more focused on quality, the time and the budget part is shattered somewhere. So how the combination of all 3 is achieved, the budget, the time, and as well as the cost with the quality. Yes, sir.
Yes.
What did you say?
Okay, I will
Yes,
reply
sir.
that.
You can have some deliberation.
The inherent advantage of this inherent proposition towards this will be there when you plan the things in advance, what Mr. Ganguly was talking. We have the CPRT, CPM network made there, things were planned in advance, and it was done on the mock-ups and trials. The cost connected and the time spent on the mock-up and the models were quite more than the when you go to the actual work. Like rightfully he mentioned about when fixing a marble, time spent for fixing the dummy marble made out of the timber were more when the actual work started. So that's how the time is controlled with a better planning, and of course the cost, since you spend your full energy to a small part of the job for which the cost variation is not a very great question. I feel Mr. Ganguly will supplement anything more.
I think what you said was absolutely right. It's planning, and planning. If you plan your work, you don't sacrifice on quality, you still maintain the cost. And naturally, if you have planned the work, you do it to a time. but all three have got equal importance. The quality, in any case, you cannot compromise because you've got stage approvals. You have to go through one stage after another stage. So there is nothing that you can do about it. Yes, suppose you have priced for 8 mockups and you have to do 20 mockups. Where do you get that additional money from? So you have to bring it out from somewhere else. You cannot do that much. So you have to keep that in mind. That yes, I can't do so anything more than this. I have to be able to do it properly and do it within this whatever is provided for. We have provided for mockups, so you have to be within that budget for mockups. Like that, I suppose it is constant monitoring, constant planning, constant making corrections as you go along.
Suchita, I would like to chip in after Mr.
Yeah.
Ganguly finishes.
Okay,
No,
carry on.
no, the reason I am telling you why I want to chip in, it is exactly in the same connection of cost and all the things. See, L&T Construction is lucky to have courageous subcontractors also. In spite of all these difficulties, Mr. Ganguly can tell us about one subcontractor, Williams. Even when he knew that he could get whatever is demanded, he refused to take the job on cost plus or people supply on supply basis. Many people resort to supply basis. They are not responsible for the productivity. This Williams I know for sure because I had worked with him also. He refused to take that kind of thing and he said, I will take this marble fixing on rate, predetermined rate. And if you remember, go back and remember, Mr. Seth said marble work was done 2 months before the schedule.
Yes,
We
yes.
had also courageous contractors, subcontractors. Ganguly.
And he actually he set the trend because he accepted the rate for marble fixing. The others had to do accept as well, and we got a rate fixed up, and the whole work was done as per it. But it went on like a clockwork. The marble work was once it got started, it went like a clockwork. That's why we saved 2 months and probably made a little bit of money in that.
Okay. Okay, great. So again, the teamwork is emphasized here. Teamwork, collaboration, these are the things which are more emphasized here.
Yes, and involvement. You have to be involved in all these things in a micro manner, such that you have the right information and you take the right decisions, so that your cost does not go haywire, and then you realize all of a sudden, oh, what have I done? I can't do anything. I've already overspent. So then it is too late. You can't then correct it. You have to do it step by step.
Okay.
It is tough. It is tough for very large projects, but luckily, this project, in spite of all its complexities, difficulties, it was quite repetitive in nature. So if you do one leaf, you have the 9 leaves done.
Similar.
So more or less, although you're tackling 3 at a time, so you're doing 3, you're learning at 3 and then repeating it twice. So to that extent, you can save some time. You can do it at a little less cost, or if you can manage. So the repetitions did help.
But Suchita, I am sure you must have heard about cost benefit ratio.
Yes.
I'm sure in engineering terms, we used to call it as a cost benefit ratio.
Yes.
Finally, this project, I don't know what was the cost benefit ratio L&T got out of that. After the project was done, even today, I think probably we are using it as a great advertisement.
Yes.
You have to
That's
add a
indeed.
value for that.
You have to add
It's a
value.
value.
You have done value.
As a matter of fact, I'll tell you another incident. We got pre-qualified for natural draft cooling towers based on this building.
Totally industrial building.
Hochtief were the main contractors, and we were then just getting into natural draft cooling towers. We had not done. Gammons were doing the entire lot, and HCC and all the rest. So we had not done natural draft cooling towers. The first one we got was in Neyveli, lignite, and we got it because Hochtief came and saw the Bahai Temple. I said, if you can do this temple, you can do the tower, the cooling tower. There is no problem. Even if you have not done one before, it is okay. So of course, AR's influence was there with Hochtief, and we got the cooling tower there.
Great.
Ganguly sir, I would like to ask one second. Ganguly sir, my question remained half, of course, earlier about doing the same project together. Now you talked about material, technology, tools, mechanization and other things. But my pertinent question, of course, without casting any aspirations on construction professionals today, do you still feel that you will have the similar passionate people available in construction to do these kind of projects?
Yes, why not? You have people. You have young people. There's no difficulty. You will have people. The leader, the leader has to make up his mind right from the top. I'm not talking of the construction manager or the project manager. Right from the top, the management. It's done. I mean, you have done the statue in very limited time. I was told the statue was done in 2-3 years time. That's a very complex. That's a very complex thing by itself, with so many international inputs, and it was done. So like that, we made all these airports in record time, and we did all that. It can be done. It's only the people on the top, the leadership, must make up their minds and form a good team and push it. I'm sure people are there to do it. Why not?
That's a great boost to construction industry.
Of course, you won't get sloggers like us, but I think people have become smarter. So they will do it in a smarter way.
Go ahead, Sujita.
Okay. So there are some questions related to the quality and the concrete. So Seth sir, I would like to ask this particular to you because you have mentioned that a lot of mock-ups, trials, and a dedicated concrete lab was also there. So any particular, there are two questions. I'll just club it. So one is you said that entire white cement was used. No gray cement was used for the petals and everything. So what was the grade of that white cement? And secondly, what were the, you mentioned about the super plasticizers as well. So which were like super plasticizers at that time, and whether for durability aspect, any corrosion inhibitors or any other corrective actions or anything related to durability aspect was done to ensure the durability.
In what I recollect, that white cement imported from Korea was 33 grade only. White cement. I will not be able to recollect. Mr. Ganguly, remember the name of the plasticizer? I don't recollect.
Yes, Asian Laboratories.
National Laboratory.
Asian Laboratories plasticizer. It was not a liquid plasticizer. It was a powder plasticizer in packets. There were a number of plasticizers which was checked and all, but this is the one that went well with the white cement. It didn't discolor the white cement. Otherwise, the white cement was getting discolored, and the concrete was not coming out as white. So that is why this Asian Laboratories was preferred, and it was manufactured nearby. I think somewhere in Okla or somewhere it was manufactured, and that is what we used. It was in packets, and we used to put that packet into the mixer.
Backside. And we have not added. We have not added any that corrosive
Corrosion.
resistant compound in the
No, nothing
concrete.
else.
So
Nothing
our
else.
full reinforcement was 100% galvanized and went through that sandblasting, so that crack checking before sandblasting, and all those things. Properly, there was no site cutting of the reinforcement hot dip galvanization.
You
So
look at the cement consumption was the
Yes, sir.
cement consumption was kept low
Yeah.
to avoid grazing, because the white cement was definitely finer compared to other cements. The cement consumption was kept quite low. Water cement ratio was, I think, 0.42 or something.
0.43 and 0.43.
And we normally achieve very high strengths. Very high
Yes.
strength. M50 strengths
Yeah.
we achieve.
Yeah.
Strength was not a problem at all.
Okay.
So Indian cements only came out later on, so we could not use Indian cements.
JK was producing the white cement, but that was non-structural grade at that time.
Correct.
Okay. So, one more question related to this. You said there was no other chemicals used, like yeah, not even waterproofing chemicals or anything. You emphasize on making the concrete more durable. So, any specific durability test you were to perform at that time? Like we have cube strength, compressive strength for cube strength. We are doing for compressive strength. These days, there are a lot of durability tests, predictive tests. Any specific test or any specifications you remember you used to do at that time for the durability?
No, I couldn't tell you
It was only
offhand.
density. It was
But
only
what I-
density of the concrete. Yes,
What
sir.
I can tell you that all these aggregates, sand, cement, was sent to Geneva, and they did microstructures test of the concrete that they produced there, and they certified it as okay materials, as well as the proportions. And that is how we came to do it. Of course, slight changes were made on the grading to see that the bush hammer comes out all right. Otherwise, the strength-wise and all that, we had no problem. We had no failures of concrete as such, because it was so much higher than what was required.
Okay.
And
Okay,
actually, there was so much of care taken on the concrete that really no one had any doubt on the concrete.
We also use one chemicals that is for curing.
That's
In the beginning we started with Asian cloth, that put all the fountains. Actually, the presentation time was too less. I would have covered after guidance of Mr. Ganguly. We used to have the fountains on the top so that water continuously sprinkle out. But then we find that it is creating a workman problem for the other areas. We shifted to applying the curing compound on the top surface of the leaves. Yes, sir.
okay. Okay. So, one more thing related to this only. Were there any specific codes you were following? Because I understand this was not a regular building, and a lot of people from different parts of the world were also involved. So, which codes, IS codes or BIS codes or any other codes you were following?
All BS.
All BIS codes.
Yes, coach.
Because this tender was framed by Flint and Neil partnerships in London, and they were the consultants to start with. They were even the supervision consultants, but later on they moved out, and it was directly supervised by the architects. But since they made the tender, and this was probably one of the earliest tenders having FIDIC conditions of contract.
Okay.
This was my first experience with FIDIC, and I'm talking of 80s. India, FIDIC came in much later. say somewhere in the mid 80s or even 90s, FIDIC came in, and then FIDIC got modified immediately. The FIDIC book used to be only so thin, the modification used to be this much. So it all got distorted.
Okay. Okay. So one interesting question is there, where you have you ever faced like any aerodynamic challenges during the design and the construction of the project?
No.
Nothing like that. I guess it was considered while designing the entire thing.
Yeah, while designing the temporary structure, especially the main staging of the inner leaves and the interior dome, and including the main structure that for the staging of the main outer leaf, wind of 1000 Newton per meter square were considered, and it was in the combination of the inner structure, it was work for asymmetrical loadings as well, with part load and the full load and the wind velocity.
Okay. Okay.
But really speaking, actual construction, we never really had that severe a storm to remember that
We used to lock the tower crane.
shake up. No, you're not supposed to lock the tower crane. You're supposed to keep it unlocked. It's supposed to
No,
shake.
that is the rail. On the rail, we used to lock it.
On the rail,
Yeah, that was my responsibility from the beginning, before leaving, as a last user, to see that wheels are locked. It should not move on the rail. Top was kept free. Jib was kept free.
Last year about this time, we had a big storm in Kolkata, that is Umpan. We just completed its anniversary, and water poured in from each window, from which the direction the wind came in at about 125, 140 kilometers per hour. And all the sealants and all did not work. So it was quite a nightmarish experience. No, we didn't have a storm problem.
Okay. So there's one interesting question for Seth sir. So you mentioned about zero tolerance. So you mentioned about the zero tolerance, like 30 mm everywhere and 34 mm at some places, at few places. So can you just elaborate more upon that? What is that zero tolerance and no negative tolerance? I mean, how it was achieved?
See, I will explain you that if you take cover to any reinforcement, if reinforcement was provided, that controlling reinforcement or allowable reinforcement is 30 mm, so 29 will get rejected, though 33 will be accepted. So that's what I meant by negative 0 and positive 3. Since main concentration and the design concept which has gone for this building for 200 years, they were just not taking any chance to have the lesser reinforcement cover to create which will lead to any cracks or something on the top.
On the bottom, on the exposed face.
On the exposed face. On the exposed
face.
On the
because
exposed face.
You could have cracks coming up and then corrosion setting in and all that. So if you have it clear, and we can follow this anywhere, it is not a very difficult thing to do.
It is not that difficult. It is very important. Yeah.
Okay. So we have a lot of other questions, but we have already crossed 12:30. So I would like to stop here. What we will do is, sir, we have some other questions. We will send it to you, and we can send the answers to participants later on. And thank you for such a mesmerizing session this was. Thank you very much. Divanshi, you can take over.
Thank you.
Yeah, thank you so much, Sachin ma'am, and all the dignitaries for answering all the questions of the participants. Now I'm thoroughly elated to call Mr. Prasad Sevekari, Secretary of ICI Pune Center, for his closing remarks. Over to you, sir.
Thank you, Divanshi. First of all, I would say that, had this been in a offline environment where everybody would have been present, these people, the speakers and moderators, would have got a standing ovation. Please take a bow from us. I must, we must clap for you for the wonderful work the entire L&T team has done and the way you have brought this story to us. This was absolutely engrossing. I'm sure everybody must have been engrossed, and they haven't assumed that we have been listening to you for more than 2 hours now. You certainly have made all of us proud. This all started when I saw a post on LinkedIn by Shyam Seth, where he had posted about a photo of model of this Bahai temple. Then I messaged him, and we exchanged the numbers, and that's how this all took shape. So I must thank Mr. Shyam Seth for posting the photo on the LinkedIn. And then, I must thank Mr. V B Gadgil, who was our mentor, who's our mentor in ICI Pune Center, and for Mr. Ganguly for being, bringing out this wonderful presentation. What I would like to say is, we will have this story with us forever. Whatever you have said, this will continue to inspire, construction industry professionals forever. And we must resolve, to be inspired to put in the same kind of intent, the same kind of effort, planning, determination, dedication, craftsmanship, the attention to minute details, in all respect to all whatever we are doing. As civil engineering professionals, let's all resolve to make ourselves proud by following the same footsteps. We civil industry professionals owe it to the society of which we are part of, and that society looks upon us to provide the similar kind of infrastructure for them to use. That's it from my side. I would like to express special mention for Sucheta Kalawar, who has taken efforts in coordination with this. I would like to see that more and more such combinations between different centers of ICI. So like we associated with ICI Ghaziabad Center, and they agreed for that. More such association takes place, and we take just such inspiring stories to civil engineering and general public all over India and maybe across the world. That's all from my side. Thanks.
Thank you.
Thank you so much, sir. Thank you so much. Now I request Mr. YTV Prasad, Zonal Head Technical from Ultratech Cement Limited, for his vote of thanks. Over to you, sir.
Thank you, Divanshi. Respected Mr. Narayan, who is in the audience, and dignitaries in the panel, ICI teams, colleagues from Ultratech. Good evening to you. Good afternoon to you all. Once Saint Ambrose said, no duty is more urgent than that of thanking those who has helped us to make the event successful. So I am delighted to have been given the pleasant duty of delivering the vote of thanks this evening. Bahai Temple, as all of us know, is a monumental structure. And it is one of the tourist spots in Delhi. When we visit the Bahai structure, Bahai Temple, so we enjoy the architectural beauty of the structure, but we do not know the effort that has gone behind it to make it really a great monument. The efforts that went behind making it a monument has been clearly brought out in a simple manner by the speakers, and also by making the speaker recall his past memories. Yes. So in fact, I joined L&T Cements in 1998. We never miss even a single sales promotional meeting without showing the picture of the Bahai Temple as a proof of capability of Larsen & Toubro Limited. So, but at that time I was knowing so much about the temple, but today I learned a lot about the Bahai Temple from the speeches of both of you, sir. On behalf of ICI Pune, ICI Ghaziabad centers, Ultratech, and myself, I would like to thank Mr. Shyam Seth for presenting in a simple way the complexity of the design of the Bahai temple and the problems faced in the construction of the temple. And also he brought out the proactive approach, that is, by doing the mock-ups and trials, and the efforts to make the temple energy efficient. During those days itself, we were thinking about the energy efficient structures. The efforts gone behind to make it energy efficient, and also the high standards of workmanship that has followed in the temple. Sir, thank you very much. So we have learned a lot from your presentation. Thanks for sparing your valuable time with us. And thank you, Mr. Ganguly, for sparing your time and also bringing your entire practical knowledge, like, learning from a university. So you have spoken about plasticizers used and how the templates were made and how the marble was, put to the detailing and all the things. It is a kind of university. It is a kind of university imparting the knowledge, and we gained a lot from your practical experiences from the presentation you have made. Thank you very much, sir, for being part of the event today. Now, Mr. Ganguly, I know Mr. Ganguly as an eminent engineer and also as a manager, but I don't know that he's a great moderator. Today I realized that, we have a great moderator among us in Pune Center to conduct future programs, and he has really brought out the relevant. Sir?
Gadgil. You're referring to Gadgil, isn't it?
Yes, sir. Yes, sir. And he has brought the finer points that are relevant to the people present here in the webinar today. And thank you very much, sir, for this moderation as well as your mentorship for making this event a grand success. Thank you, Mr. Gadgil. And the teams ICI and ICI Ghaziabad. ICI Pune has put relentless efforts. I think they have started this about 1.5 to 2 months back to make this event a reality. And since then, so they are working on that. And today they make it a grand success. Thanks to the entire team of ICI Pune. And ICI Ghaziabad, I sincerely thank the team ICI Ghaziabad for agreeing to associate with us or to jointly organize this program. And I sincerely thank Ultratech Cement Limited for supporting this program by providing their platforms, and also Team Ultratech for their untiring efforts to make it a grand success. Ladies and gentlemen, once again, I would like to say that we are all most grateful to all the speakers on this forum. We thank you, the speakers and moderator, for being with us this afternoon. And last but not the least, the audience, without whose presence no event can be successful. And also there are about 1,450 participants who have participated in this webinar. And because of the charm of the, style of presentation of the speakers, they were there till the end. My sincere thanks to all the participants for being with us patiently, for attending and being with us patiently. And also we assure that from ICI and Aerodynamic partnership, we would bring such knowledge-based programs in future. Thank you very much.
Thanks to everyone. Start.
Thank you, sir.
Yeah.
Thank you. Thank you.
Thank you, sir. Thank you very much. So now we are ending the program, right?
Over to Dianshi.
Yes, sir, we are ending.
Thank you.
Thank you, sir. Thank you very much. Thank you.